Good day, I'm Chong Chun Sen, student from University Malaysia Pahang, and I would like to share with my research work with the title Comparison of Support Vector Machine and Friis Equation for Identification of Pallet-Level Tagging using Radio Frequency Identification RFID signal. The contributor for this research work, they are Chong Chun Sen, me myself, Ahmad Fakri AB Nazid, Muhammad Aizat Zakaria, Muhammad Azrai Muhammad Razman, Anwar PP Abdul Majid, and Azura Azmi. Before I present my research work, I would like to present the presentation outline to you guys. First, we start with the introduction and problem statement. Next, we're going through some related works. Furthermore, we'll discuss the methodology that I apply. Last but not least, I will explain regarding the result and discussion. Lastly, I will go through the conclusion. The purpose of this research work is to examine the efficiency of the pallet-level tagging classification method. In the indoor positioning system with applied RFID technology, it is possible to locate particular items or goods in the warehouse, but it will facing a difficulty for the workers to identify in which particular level. Therefore, to track the structures of the RFID signal, whether it is in a stack or in a case in a warehouse, it will be our objective for this research work. This is because the manufacturers need to ease the logistic cycles in the indoor positioning system as much as possible in order to misplace the products through the warehouse management system. It is therefore necessary to predict the early stage of the RFID pallet phase. Based on the literature review, the related work can be split into two different parts. First is the theoretical formula, which consists of radio frequency that apply Friis transmitting equation, time difference of arrive or angle of arrive, and phase difference of arrive. The next one will be applying the empirical formula. It will mean that they are using machine learning with different kind of approach such as support vector machine, artificial neural networks, decision tree, and bias theorems. The theoretical formula utilizes the receive signal strength to measure and determine the location of the reader antenna. Conversely, empirical formula using machine learning technique to identify the analysis the status of the RFID signal in the reader antenna depends on the variety of the level group. In the pallet-level tagging identification, there are two most common approaches that has been applied. First is the landmark-based approach, and another one is the receive signal strength indicator-based approach. Landmark-based approach stands for the location identification based on dynamic active RFID calibrations. It is a method that utilizes the idea of the reference tag and use of the predefined location to classify the depth of the pallet case, whereas the receive signal strength indicators RSSI approach is based on the calculation of the power present in the transmitting radio frequency. Various classification methods such as of the support vector machines, Friis transmitting equations, decision trees, arrive of angles that has been used to build and create the algorithm that enables the computer to read and from the data and make data-driven prediction without being direct computed. From the literature review, there are only limited studies on the pallet-level tagging identification, and this is the summary of the literature review. For example, the first prediction of the RFID tag detection for a stationary carton box. The level model they are using 10 level with tagging in front, back, left, right, bottom and top of the carton box. We've applied the RSSI approach with using SPM. And the next one they're using to measure the sensitivity of different location of the tag with the level model of 20 tag in a stack and apply RSSI with Friis equation. Following by the two, they are using landmark approach, which going to locate the indoor location sensing using the active RFID and RFID data clustering algorithm for improving the indoor network positionings. Last but not least, they also have some researchers apply clustering method. It means that the unsupervised learning method using k-means to clustering the pallet levels with in the pallet boxes. Lastly, they are using compare with different kind of machine learning algorithms using RSSI to differentiate the levels detect count on the RFID localizations. Based on the related work that has been mentioned previously, then we can summarize from the literature review to looking for the methodology that apply for these system structures. We will start with the pallet level model and then going to data acquisitions. Next, we will going for the programming platform. Lastly, is going to do the model buildings. In the pallet level models, we are doing the cross mapping with the tagging. We're using electronic product code. It means that the EPC code of the RFID. In the data acquisitions, we're going to collect the data from the RFID antenna that regarding the receive signal strength at the sampling rate of 10 Hz. And in the programming parts, we're using Python to code all the program, which include the library, pandas, sklearns, nums, and RSS Friis. The data acquisition from the receive signal strength is undergoes the features engineering. It means that the feature extraction that transform the data into functionality that can be used with the classification and statistics. We apply the statistical analysis techniques that extract the features into max, mean, mode, median, means, variance, range, skewness, and kurtosis. The data is that extracted is going to split for 80 and 20 with the testing and training. The 80% of the training data is undergoes a deep analysis for 5-fold cross validation in order to determine the error rate. The next classification algorithm in over here we apply support vector machine and Friis transmitting equation. All the parameters are set as the default value. In the performance evaluation part, there are 4 evaluations that we're going to looking for. First is the classification accuracy, second is the precision, third is the recall, fourth is the F1 score. In the multi-classes classifications, that is needed for the macro and the weight average. This is because we're going to know whether the sample size is going to affect the evaluation performance or not. In result, we can see from the confusion matrix from these 4 tables that from the SVM training, they have the classification accuracy of 90.52%, and in the testing part, they have a 90.17% of the classification accuracy, whereas in the Friis training, they only have 70.25% of a classification accuracy, and there is the 71.25 of the classification accuracy in the testing part. The elevation performance of precision, recall, and advanced score can be seen from these 2 tables. First one on the top is means that the training model of the SVM and the Friis, which include the macro and weights. We can see over here the precision, recall, and advanced score seems like quite stable, no matter is in weight or in macro. But it is obviously that SVM have a better performance than the Friis equation. Same goes in the testing model. The training models that sample size was used for 4,800 and the test model was 1,200. As a result of the SVM model, the performance metric can be concluded that they does not affected by the sample size. In the meantime, the Friis model have a slightly different in the macro average of and the weight average of plus minus 0.01 in the precision and recall for the training set and testing set. In this overview, a comparison of the SVM method and the Friis transmitting equation has been shown by extracting features from the RFID reading to differentiate the pallet level tagging to predict the pallet level with the actual level. The evaluation begins with the combination of 9 selected extracted features that are analyzed from the time domain features ISSI. The empirical formulas of linear SVM model has the better performance compared with the theoretical method of the Friis transmitting equation, which have a highest classification accuracy of 90.52% and 9.83% of the error rate in the test dataset. In the multi-label classification, the overall performance of each level has shown in order to assess the problem of the category instead in a precise label. Further programs could be achieved by using a more suitable classification technique such as artificial neural networks, decision tree, random forest, Navier Bayes, amongst others, to determine its efficiency in classifying the pallet level of the text. This is the end of my presentation. Thank you. Don't hesitate to contact me if you have any questions. My email address is cs_chong@hotmail.com. Thank you.